Welcome to this short video where we will understand of how to insert a node in a given singly linked list at a particular position. So let's understand what this position means. So this list, which has 4 elements, would be marked for position for each node, right? So the first node is marked at position 0. This is at 1, 2 and 3. So this is just the way indexing is done in an array, right? It starts from 0. So similarly, positions are marked in a linked list starting from 0. Yeah, this is the assumption that we make. So let's see of how a node would get inserted at a particular position, right? So let's say I want to add a node um, at position 2, which would mean the new node would get inserted between the old positions of 1 and 2 and the links would change, right? So let's look at the set of cases which is the trivial case. Yeah, so the first trivial case would be a scenario where position is equal to 0, right? So which would mean you want to make the insertion of the new node at the first position, right? So this would work even if the list is empty or if the list is non-empty, right? So this is case number 1 to be handled. The second case would be a position which is well within the length of the linked list. For example, you see 4 nodes here and any value of position being in the range from 0 to 4 is valid, right? So that is the case that we will handle here. For example, as I said, let's say I'm talking about a new node to be added at position 2, right? So what I should do is I will have to change the link of this node which is at position 1 to hold the address of the new node, and the new node will hold the address of the node whose data field is 12 now. So as you can see, the positions of nodes after it would change, and this will be updated accordingly, right? So there's an increase in the length of the linked list. And let's go ahead to cater to these two scenarios of position being 0 and any valid position being given to us, and how do we handle it. And we will also have to handle the case where the position may not be valid. For example, this list, as you can see, has 5 nodes, and if a user says that he wants to insert at a position 10, it's completely invalid. So we will have to handle this case also with the code, right? So let's look at the code. I would call this routine insert position, which takes 3 parameters: the address of the first node, the data that is to be inserted, and the position at which this insertion should happen. So let's get the new node created by making a call to get node routine, and this would be our case 1, right? Case 1 where the position is 0. So I understand the new node next should become first, and first is a new value, and when first value is getting changed, the calling function should be aware of it, and I hence return first here. Okay, so if it's not case 1, I understand I will have to traverse the list and find a position for it, right? So traversal is something which I do with this for loop. So let's look at the for loop that we have here. I is the loop variable, and I would stop when it is just before the position, right? So if I'm looking at insertion, let's go to this diagram. Let's say I'm looking at an insertion at position 2, I would want to stop at 1. So current is the local variable which will help me traverse the list, which starts from first but keeps moving, stops one position before. So if you want to insert at position 2, you will stop at position 1, or if you want to insert at position 5, it will stop at position 4. So it's just one step before. Okay, so after it has stopped, the next job would be to change the links. So I would say establish these two new arrows in my code. So let's go back to the code. So when I come out of the for loop, I understand that I have found the position of where it is to be inserted. But closely look at the for loop. There's one more condition that we have put, that the for loop should exit when current becomes null, or this is a case when you want to insert at a position which is well beyond the length of the linked list, right? So you would want to tell the user that if you have come out of the for loop for the reason that current became null and you haven't reached the position, it basically means it's an invalid position, right? So you tell the user that it's an invalid position and you have nothing else to be done, and hence you return back to the calling function. But if you have exited the for loop for the reason that you have found a position, this is the set of code that will be executed, right? So what I would do is, let's come back to the list. I understand this is my current. I will have a variable temp also being used in my code, which is which would be one second. So let's assume this is the value which is to be inserted, and this is the list originally before the insertion. So what I would have is current and temp would be initialized as seen in the diagram. I will say current's next should be new node and new node's next should be temp, which basically takes that link, right? So we will have that done in our code. I will say current is whatever is temp is whatever current next is, and the next of current should be made new node and new node's next should be made temp. So this is the case of successful insertion of a node in between. This will also handle the case of the node insertion at the rightmost end of the linked list. So after we are done with it, we will have to return back to the calling function, and as we have seen, the routine insert position should always return a value or a variable of type struct node star, and I will have to make sure all cases return the variable first. Yes. So this gets us to the end of understanding this routine of insertion at a given position in a given linked list. Thank you.